Merci Yves. Et enfin, pour terminer cette série de présentations, je vais donner la parole à Matthias Schuler, fondateur et directeur de Transsolar.
Merci, Philippe. So I'm closing the session and it's in English. My French is too bad to bore you with my... So I took from Lutz Increasing Urban Density as the title and Reactive Design as a subtitle. And I will lead you asking, okay, reactive design. One example of reactive design we just see downstairs, the little cloud at the Fondation EDF. And then reactive on what? Because if we split reactive design, reactive on IPC 2014 and One Planet Living balance. And then reactive design for what? Reactive design on buildings, on cities, probably on the way we live and on our expectations, how we are thinking how we need to live. So on clouds, there is a certain physics in reality which depends a lot on the height, on the pressure. So whatever, down here you have whatever, 33 degree, the dew point is 15 degree because there's around 11 grams of water per kilogram air. If you lift it up to 1,000 meters, the temperature drops, the pressure drops the same time, and if you reach 2,000 meters, then the dew point and the temperature is the same, then you get condensation, then you get the cloud. And you need aerosols, little dust particles, to make this condensation happen. So there is no way to, in a certain way, adapt this design into an indoor cloud because you don't have the height. So in a certain way, we had to put physics the other way around. In our case, it's hotter up there and it's colder down there and humidity is in the middle. So in a certain way, you have to adapt reactive to make sure that this cloud is then appearing indoor. And a great thanks to Arnaud, Sabine and the Paris team to make this happen downstairs, because I can tell you, if you, and I think this is our 9th or 10th cloud we are doing, it's always at the end to do the fine adjustment to make the cloud appearing is a nightmare. So this is reactive design. Now, what is why we have to react? And we have seen already some slides on this. This is out of the IPC report. Just the development. This is in this case not CO2, but the temperature. So in a certain way, where we are, where we're ending, will we keep it in the 2 degree, one of the big discussions at the COP21. And a consequence out of this temperature increase is as well, this is the change in minimum catchment, because we're living a lot out of the blue planet is based on water, and we're living a lot out of this water. Now, this is just where in a certain way, you get up to 50% less catchments. And these are the big kind of natural food resources. And we are getting more people. We need more food and not less food. So in a certain way, it's quite interesting to see that temperature increase and whatever change of precipitation and dry seasons is, but there are as well other consequences which will directly influence us. So this is definitely something. And then there are politicians, and they talk about targets, and they set targets for European roadmap 2015, and they said in 2050 we are down there. But today politics is not matching it. So it looks like everybody knows where we have to go to, but we ignoring, we will never make it. What is interesting, and this is now on German code, that in respect of the heat consumption per square meter, energy consumption for heating dropped down from 1970, where we were in the range of 250, to today in the range of 100 by code. New buildings have to be at 70. The problem is the surface per head, the surface per people increased in Germany. This is now the German numbers, between 25 square meters per person. Nowadays today we are in the range of 47, and it may go up to 60. So in a certain way, what we on one side saved by better envelope, we are consuming, that we are requiring more space. And then this is my story, that then finally someone is living on its own on a 100 square meter apartment, and he doesn't have to go out for shopping because he or she has a big refrigerator. So once a week, they are only leaving their apartment. And this is not what, this will kill our cities, because if people are not going out, there is no life in the city. So then we have to look on our personal balance. And this is Mr. Müller. He lives in a code building on 200 square meters with 2 people, and he's driving a C-Class Mercedes 15 kilometers, and his balance is like 1,500 kilowatt hours. Then there's a guy who lives in a passive house. He really does something really substantial. He's buying a bit bigger car, and he takes 30 kilometers. He lives with the whole family, and this is 160 square meters. And mobility, in a certain way, is killing his personal balance. And then finally, there's the last guy who lives downtown Paris in an old building, but on its own under 130 kilometers, and he takes the bike. But the building is killing his balance. So we really, in a certain way, we always have to look on our personal way to do it. And I didn't include traveling because this is the next step, something we have to look at, that in a certain way we can save the energy in our building, and you saw something you then are consuming in your car. But if you take a cheap flight to the Dominican Republic twice a year, you're killing all your balance. And I know when Wolfgang, one of my guys, started to do our private personal CO2 balances, and typically we at Transsolar are 10 times worse than the typical German guys because we are traveling too much. That's something we have to think about, how we can, in a certain way, change this. So this is the 2015, this is the approach the Swiss people did, and they defined the so-called 2000 watt society approach, because they said, if we take the planet today, the planet in what it can take and digest more or less, the planet can digest around 8 billion tons of CO2 a year, which means all the plants, the seas, the land mass, in a certain way, this would be a kind of a CO2 emission the planet can take and keep it in the balance. This means slowly or pretty close, we are 8 billion people, so each of us has 1 ton of CO2 per year. Today, I think the Germans are at 11, the Swiss people are at 12, I think the French are similar, 11, 12 tons. So we have to get it down by a factor 10. So that's not only 50%, that's a lot. So, and the Swiss kind of developed this, that from there today, 6,000 watt society. So this is a 6,000 watt heating element which runs 8,760 hours permanently. This is reflecting our today total consumption, and you have to get it down to keep it in to the 2,000 watt, where then at the end only 500 comes from fossil fuels, because this is the 1 ton we are allowed. The other has to come. And what was interesting, they defined it a long political target in 2150. I'm not sure if the planet is still there. But what is interesting, the Zurich City Society, in a public vote, 75% of the citizens of Zurich decided to tell their guys they have to reach it in 2050. So in a certain way, the people of Zurich were ahead of their politicians. And now they told them, and this is pretty close, that's not so long, 35 years, they have to get it down to this level. So I think that's quite interesting. Today in Zurich, you can build an apartment without parking as a developer, as long as you offer, when you sell the apartment, a kind of a card for the public transportation. I think this is how politicians have to react on requirements. And we heard this, that we are moving to cities, so in a certain way, we have to solve the problem in the cities. This was parallel to Eve. In the same competition of this Paris 2030, we worked with Finn Geipel and Julia Andi, and we developed a model which we called Paris Métropole 12, with certain kind of hotspots where we have higher densities and then spaces in between where hopefully there's more nature. What is interesting, these are the French numbers, and they're quite similar to the German ones. 25, this is today 45 square meters, lonely people, 65 square meter in one apartment. What is interesting, more people in the city means higher usability of the infrastructure. So we have to get more people in the cities to make our public transportation, our infrastructure more efficient. This means more life in the city, because if you're living denser, and this is quite interesting, in Basel, today they find out they have, in the last 15, 20 years, they got around 10% more citizens in the city, and suddenly now the people are protesting that there are too many people. But if you compare the today number to 1965, they are still 30% below. So in a certain way, it's kind of what we are expecting. So in Europe, it's clear cities are built. So we have to work on our existing cities, and there's not a big of extension happening. What I think is quite interesting, if we are squeezing more people into cities, and this is quite close to what Lutz presented, there is a higher demand of the public spaces, because you will spend more time outside. And one result, in a certain way, what is interesting, we discussed with one of the big Chinese developers who is developing 150,000 apartments every year. They found out that the apartments they're building today, they are too expensive. Normally, it's 85 square meter for a couple. They get 2 kids. They get the grandparents in because they have to raise the kids. So there are 6 people living in 85 square meters. Now, the prices get up, and now the couple cannot afford it. What they found out, if they do the public spaces around their apartments better, a higher quality that people can spend more time outside, they can reduce the footprint of the apartment to 65 square meter and make it affordable for the couple to live in there. So this is a pure economical driven finding they are now doing to increase the quality of the spaces around the buildings. So my radical vision for 2030 would be, we have to get it back to 25 square meters per person. And if you talk with people in Tokyo, it's not such unexpected. So in a certain way, but if we do this, we have higher densities. There are some positive effects: thermal buffers, self-shading, microclimate, energy neighborhood. We can live from each other, but there are as well negative effects. We have to do it very carefully: city ventilation, heat island, noise island, less nature. Because this is, I don't know what is in English, the Nachtigall in German. Nightingale, the nightingale. Berlin is the head city of the nightingales. There are more nightingales in Berlin than in whole Bavaria. So in our big cities, nature is surviving better than in our industrial agricultural land. So that's something as well to have in mind. You can live on a small footprint. This is a little house we developed with Renzo Piano, 6 square meter living area. You're living a lot outside, because otherwise, if you live there with 2 people, you may kill each other. So, but it's totally autonomous. It lives on its own. It has, and you get a sign. Today, you can decide either you take a shower or you cook your spaghetti. So in a certain way, you decide on a certain budget you're spending. And it's a kind of an assembled tool element. Now, taking this into an approach, this was Master City. Some of you know we built this little part of it. 50,000 square meters were built, but we could show in this very dense development, we could keep it around 10 degrees below the ambient temperature of outside the city. And that's not our invention. This is just redoing what the master plan or the citizen planners in old Sicily cities, in Sicily, you can see these old medieval cities which stay 10 degrees below ambient. So we are just repeating or reinventing what we forgot. So, oops. They are the measured. We measured the data. You see, today 400 is the typical consumption kilowatt hours electricity. We designed it for 65. We measured after the first year 100. So we're still above, but it was a quite positive surprise for us. And this is measurements in the in the really hot July, August last year, 50 degrees out in the desert, and you still get 40, which is still hot, but 10 degrees better than outside. Now, what is amazing, out of the lesson that it works, this is the new master plan of Mastar City. So financial doubts finally led to that they will build at the end 81-meter wide avenues. you will be dead crossing this avenue in summer because this avenue will have 60 degrees. So as a consequence, 50% of the year, the outdoor urban areas will be too hot. Instead of the little example we built where it was down to 11. It looks like sometimes people are not listening or money counts more than comfort. So I'm concluding in a certain way, looking a bit on materials. Our planet is a complex system with interconnections we totally ignore. We use 40 billion tons of sun every year. We build concrete. But where's the concrete coming from? This is sand rubbery in Morocco. A total public sand beach disappeared over 2 weeks. Kind of just been sold to whatever, the Middle East, to build some skyscrapers. And we saw this fire last week. Putting foam on the facade is probably not a good idea because it burns like a light. So that's quite interesting. So this is why we are working on new materials. This is lightweight concrete, a house we built in Stuttgart, which is not as good as insulation, but it's a quite good impact. We are developing it further. This is a project we do with Mike Schleich and Barco Leibinger. So an element where the wall, a monolithic concrete wall, becomes the wall, the insulation, the solar collector, the heating element. So it's one element with multiple functions. And we did a smart material house. And I'm concluding, this is a vision we're just developing this is downtown Berlin. This is close to the Alexanderplatz. This is densification. So we are putting this little 10-story high-rise buildings made out of this precast lightweight concrete into the urban texture. There is enough space still. Nature would probably still survive there. So we have to think on it. And reactive design needs collaboration. A good example for tonight with the architects, with the other engineers, and it needs open minds. Thank you.